Okay, but yeah, so the example I had given on Wednesday for like the most basic form of this is like, okay, if I want to know the average height for every student at Cal Poly Pomona, I can't reasonably take the average height from everybody in our class and say that that's the average height for everybody at Cal Poly, right? And so what we do instead is we take that sample statistic, the average height for however many of you are in the class, and then I add and subtract a number to that, and I give a range of values instead, right? So that's what we had kind of done. We did this with the census. If the mean income that they found was about 3,500, then they're not going to say that that's the average income for every household. They're going to say the average income for every household is between 3466 and 3566, right? So it's better to give a range of numbers because you don't know for sure what number it's actually equal to, but you can say with some sort of like confidence level, we're going to learn about that today, you can say it's between these numbers, right? And so let's do this one. Construct an interval with the sample mean x bar equals 356 by adding and subtracting 19. And I want you guys to write it in this interval notation, oops, and this inequality notation. All right, so first we have to figure out x bar minus 300, or no, minus 19, and x bar plus 19. That's 356 minus 19. Oh, I have it right here. It's 337. And then this one is going to be 375. So my interval notation, which number am I going to put first? Yeah, the 337, because it's always the smaller one, right? And so style, I just realized I was using a different color on Wednesday. I'm going to have 337, and then I'm going to go up to 375. So that's my interval notation. And then for inequality notation, we're instead going to have something that looks like this up here with mu and the inequality signs, right? So I'm going to say that mu is between 337 and 375. So is everybody okay with that example? Do you have any questions about either one of these notations or what I'm doing here? Okay, so let's go to page 2. So we'll leave that up there if you're still copying. And so here, let's start talking about confidence intervals. So this is all of chapter 7. This is what we're going to be focusing on. And so a confidence interval, oops, very small. It's a range of numbers that we believe the population parameter, which again, that's either going to be mu or p, to be within. So we can maybe say that this was a confidence interval, but probably not, because confidence intervals are constructed in a very like particular way, which we're about to see. But they're formed essentially the same way, taking one number and either adding it and subtracting it from the same sample statistic. But the way we're going to have to actually find that number ourselves. But so here, yeah, these confidence intervals are used to estimate parameters. right? And so those intervals that we were making, we're calling them confidence intervals now. And this is what I was just saying. They're constructed by taking your sample statistic, which is either going to be X bar or P hat. And you add, so an adding and subtracting a single number from it to get two different numbers. And these two numbers form your interval. So this right here, this example that we just started out with, is a perfect example of what's going on here. This is just kind of describing it in words. Okay, so the next thing that we have to focus on when it comes to confidence intervals is how reliable is our estimation, right? That range of numbers that I gave you, is mu really going to be within those? And so we can talk about that now. And so here, every confidence interval is going to have what's called a confidence level paired with it. And this confidence level is going to be given by the letter C, and that's a lowercase c. You know, it's hard to tell the difference. What this confidence level is it's a percentage between 0% and 100%. And what it does is this confidence level is the thing measuring the reliability of our confidence interval. This percentage is what determines the number that we should either add or subtract, or we have, not either, but we have to do both. Add and subtract to the point estimate. Okay, so are there any questions about anything so far before I give you the next definition? Is everybody okay up to this point? Okay. So if you don't say no, then I'm just gonna move on, right? But so this next definition is actually something that we've seen before. We used this in chapter 8. We just used it a little bit differently. And so here, the critical value is a value. And so you guys remember critical value from hypothesis testing, right? And so I'll talk about that in a second. But for now, I'm gonna just give it the letter K. We are not going to be using this other than right now. So not a permanent variable. And I guess what I mean by permanent variable is like S is a permanent variable, right? Like S can only mean one thing, but we're not going to keep using K. It's just a placeholder for right now. What it is, it's just some number such that the area under the curve between negative K and positive K is equal to the confidence level. And so if you look at this picture down here, this C would be our confidence level, right? And so, I don't know, let's just say that our confidence level is like 95%. If the middle of the curve is 95%, what did these pieces have to be? Yeah, in total, it would have to be 0.05. So when I calculate one piece, I would do 0.05 divided by 2, right? Because the remaining area would be 0.05, and then I have 2 pieces, and so I split it in half. What else does this kind of look like? Like what? So there was 3 tests that we had, right? There was left-tailed, right-tailed, and two-tailed tests when we were doing hypothesis testing, which, by the way, this is like different than hypothesis testing. But here, which test, oops, would this look like? Would you say that this looks like?
Two-tailed.
Yeah, the two-tailed test. And so this right here, and keep in mind, that's when we talked about the critical value also, right? So if we were still in hypothesis testing and we were testing mu given sigma, I would say that this is negative z sub c and this is z sub c, right? And so what would this value, or what would these 2 pieces, what would the area of those pieces be given by? It's one of those permanent variables.
Alpha.
Yes, exactly. So this would be alpha over 2 and alpha over 2. And so that's kind of how confidence level and significance level are related, but keep in mind that that's only going to work for a two-tailed test because your confidence level is always trapped between negative k and positive k, or negative z sub c and positive z sub c. And so we'll kind of talk about at the very end, once we finish hypothesis testing, that's when we're going to start really going into the similarities between hypothesis testing and confidence intervals. But for now, just kind of keep all of that in mind. So I'm going to erase all the purple. But so yeah, that's just worth mentioning. So are there any questions on this page before I move on to the next one? Okay, by the way, class is going to be a little bit shorter today. Once we finish this next page, I'm just going to call it a day. I don't want to start 7.2 until we come back from spring break. But so here, I'm going to scroll and I'll try and leave some of that up there. Okay. So to actually construct a confidence interval, we're going to need that to figure out what value to add or subtract to our sample statistics. So let's say I'm working on a problem. Let's say I'm doing the same average height for everybody at Cal Poly, right? I gather the average heights for all of you in the class, and I find that the average height is, I don't know, 5'4". Then I'm gonna need to figure out what number to add or subtract to that, or to add and subtract to that 5'4", so that I can give a range of values for everybody at Cal Poly's height, right? And so here, that number is called the margin of error. Oops. And so what this is it's the number of percentage points. And so percentage points is different than percentage, right? If you were to go from 2% to 10%, you've increased not 8%, but you've increased 8 percentage points. But I want to say going from 2% to 10% is actually increasing it by like, that's where I have trouble with. It's not 8%, right? You didn't increase it 8%, you increased it like 2% to 4% would be 50% increase, I want to say. But that could be wrong. All I know is 2% to 10% is an 8 percentage point increase. And so, yeah, that's what I mean by percentage points. But so here, the margin of error is the number of percentage points that the sample statistic differs from the population parameter. So how does X bar differ from mu, essentially? And so to find this critical value, or no, not to find the critical value, to find the margin of error, you're going to take your critical value and you're going to multiply it by the standard error. And so all these notes are, so don't worry about like what these values should equal to for right now. I'm just giving you definitions. That way, when we start actually, what's it called? When we start actually constructing confidence intervals, you kind of know what all of these words mean already. But okay, so here, the next thing that we're gonna do is interpret our confidence intervals. And so our confidence intervals are always gonna start out by saying we are however percent confident. So if our confidence level is 90%, we're gonna say we are 90% confident that, and then we're gonna follow it up with some stuff. And so here what we're gonna put is we are, and then here I'll put like C in brackets so that you know to replace it. And so like, for example, if C were 90%, I would say we are 90% confident that what goes after this is, so do you remember when we were interpreting our hypothesis tests and what you had to do was you basically had to go back up, read the problem statement, and copy the problem statement? That's essentially what you're going to be doing here. And so if I were doing my Cal Poly heights example, I would say we are 95% confident that the average height for every student at Cal Poly. And so here you need to insert your population. You just need to insert your population. And so if I'm doing my example, I would say that the average height for all CPP students and then once I write that out, I would follow it by is between, and then I would insert the numbers found. Okay, so I know that we don't actually have an example to do here, but does this sort of make sense on its own? Do you have any questions about what's happening here? Does my example, okay, cool. Does my example with this like heights make sense? Like, does it kind of help you see what I mean? Okay. Huh. Okay. Hang on real quick. So this next box is basically just kind of like what you need to do for every kind of problem. And so the very first thing that you're always going to do is check the requirements. So that hasn't changed from hypothesis testing to confidence intervals. It's the same first step, check the requirements. And so the next thing that you're going to do after that is you need to figure out which variables you're given, which again is very similar to hypothesis testing, right? Remember when we talked about this the last time we talked about hypothesis testing, you start by figuring out if you're given mu or p. You're going to have to figure out something very similar here, right? And so at the end of this chapter, we can make another map like that. And so what we're going to have after you identify the variables is that's when you calculate your margin of error. And this is going to be given by the variable e. Oh, cool. Lenny, you got in. After you figure out what your margin of error is, and so here, let me just put a little note. So you're going to find the margin of error using the confidence level. And this confidence level will be given. It should always, it's very similar to alpha, right? If you were always given alpha, you're always going to be given C. And so after you do the margin of error, you're going to take it and use it. So you're either going to calculate X bar plus E and X bar minus E, or if you're given P instead, you're going to do P hat plus E and P hat minus E. But either way, you're just going to have to find those two values. And then what you're going to do is your confidence intervals should always be given in interval notation. And the very last thing is to interpret. Oh, I spelled interpret wrong. So real quick as a little mini example, I'm just gonna like make something up. So let's say I'm interested in I don't know, what am I interested in? The number of times a person goes to Carl's Jr. throughout the day, or how many people go to Carl's Jr. throughout the day. Let's do that. So I take a sample for 30 days and I find that the average number of Carl's Jr. visitors per day is, how many people do you think go to Carl's Jr. at school per day, like while the coronavirus isn't happening? One? You think one? No, I'm gonna say like 150. Let's do that. Let's do 151 so it doesn't sound so made up. And so 180 per day. Okay, yeah, so 151 is kind of low, but that's fine. All right, so here, that's gonna be my X bar then, right? Because that's from my sample. I found that the average was 151. And again, I'm not supposed to know mu at this point. What I wanna do is I wanna estimate mu. And so, oh here, let me move this real quick because there's more I need to say. I also have a margin of error of, I don't know, let's say 18 people at a 95% confidence level. And then yeah, my goal is to estimate mu. X bar is still 151, it looks like 157. And then E is gonna be 18. C, I'm gonna consider it as 0.95, right? I'm gonna convert it to a decimal, same way we did with alpha. And then, so my confidence interval, that's gonna be, what is 151 minus 18, 133. And then 151 plus 18 is 169. And so that would be my confidence interval. And so then my interpretation, which is the point I wanted to get to, my interpretation would look like we are 95% confident that the average number of visitors or the average number of people to visit Carl's Jr. is between, or here, and then should kind of add something. So like up here in my little mini example about the heights, I included the word all, and you want to do the same thing somewhere. And so here, I kind of want to specify it's not just for the 30 days that I sampled, but I'm estimating this for every day possible throughout the entire year, right? And so what I'm going to say is I'm going to say the average number of people on any given day is between 133 and 169. So are there any questions about this example or these notes or anything like that? I'm just gonna wipe that out. Yeah, Jake, give me a few minutes. Let me make sure nobody has any questions about these, and then I'll see if you have questions about the project. Oh, I can't do that. Okay, so here I'm gonna stop the recording.